He's assistant professor at WSU.
All right, thank you very much. So I'm going to be talking today about some work that we started just this year with Dr. Griffin LeHue, Dr. DeVetter, Dr. Benedict, and my graduate student who's done most of the work for this project, Cheyenne Sloan. And so I'll just put the caveat out there first that this is the first year of data for us, and so it is very preliminary work, but this is something we hope to continue for a few years. So if you just kind of, for me at least, coming from being new to blueberry systems, if you look at kind of what's been done before, there's a lot of work been done on nutrient management, and especially nitrogen management, with variable recommendations. So these are just a couple of figures pulled out from some of the work that's been done. But for example, some of Bernadine's work and in Oregon, and also some of the work up in British Columbia. So you see things like, for example, no differences in yield above 50 pounds per acre for nitrogen, or yield increases in a British Columbia study of up to 106 pounds per acre. The figure that's in the Oregon State University Nutrient Management Guide is 165 pounds per acre nitrogen. And one thing that I wanted to kind of emphasize about these is a lot of this work's been done on what would be considered in a lot of places high organic matter soils, but for some of our soils up here in northwestern Washington, these are actually fairly low organic matter soils. So the first two studies I mentioned, they're right in the 4 to 5% organic matter range. And so the question we had was really, how does organic matter factor in? So this is just a map of, this is kind of the area we're in right now, right? You can see Whatcom County up there, up here in the north, and then Skagit County there. And there's a lot of these peat soils there. So these soils that, as soil scientists, we call them histosols, but these peat soils that have pretty high organic matter content. So we define it as anything above 18%, but these can go up to, we've seen as high as 53% or even higher. And so we really wanted to focus on how does soil organic matter affect these nitrogen fertilization guidelines. And so if you look at the soil tests you get in a lot of cases, this is not from a grower's field, this is just one from our station, but usually they will try and factor in what's coming off of organic matter with this ENR, the expected nitrogen release from the organic matter. And this depends a little bit on the calculation will depend on the soil testing lab, right? So I don't know exactly what calculations they're using to derive these equations. You can see the same thing here, but you can see that in both these cases, even with a relatively low percent organic matter for this area, 2.4% there, we're at 3% there, you're still getting quite a bit of nitrogen expected to mineralize from these soils. But the question is, how does this factor in these soils that might have, if you extrapolate these calculations out, right, for a soil that has 50% organic matter, 40% organic matter, even 30% organic matter, that's a lot of nitrogen coming off. And can we really rely on those numbers that have been developed at lower organic matter rates? Or do we need to understand our peat soils a bit better to be able to adapt nitrogen management? And so our research questions were basically, what is the contribution of soil organic matter to plant available nitrogen across a wide variety of soil organic matter ranges? And we hypothesized that one, we could hopefully predict nitrogen release just from soil organic matter, that number that you already get in your soil fertility test. And two, that some of the equations, those ENR numbers that you get that are developed in lower organic matter soils, the expected nitrogen release, won't necessarily work well for higher organic matter soils. And our second question was, how does the nitrogen fertilizer requirement to optimize yield differ among soils that differ in organic matter contents? And we thought that higher nitrogen rates are going to be required to maximize yield where you have lower soil organic matter. And so we have really two parts to this experiment. The first part we did in the lab, just because what you can do in the lab is you can control a lot of the nitrogen loss pathways. So, in the field, you can get nitrogen leaching, you get potential gaseous loss pathways, you get nitrogen uptake by the plant. So there's just a lot going on in the field. You also have fertilization coming in. And so we can't see quite as well the net mineralization, the net release of nitrogen from the organic matter that's in the soil. And so we brought this into the lab. We took soil samples from 10 fields. We did 5 locations in each field and kept this separate to look a little bit at spatial variability. And we had soil organic matter contents that ranged all the way from 3 to 53%. So quite a big range here that we're encompassing. And this is all in Skagit and Whatcom counties. And there's just a tremendous amount of variability there. And then we, using data from AgWeatherNet and the soil temperature conditions at 8 inches, we incubated those at those temperature conditions for 6 months, representing the temperatures from April through September. And then we measured plant available nitrogen. So this is all still a bit preliminary. We're still working on some of this data, but we're looking at just nitrate and ammonium concentrations in these soils that we incubated over time. And then we also had a field side to this experiment. So we applied either 20, 50, or 80 pounds per acre of nitrogen at 4 field sites with soils that range from 5 to 44%. And the idea here is that each of these field sites differ in, we tried to standardize as much as possible, number of hives, that they're Duke cultivars, that they're all mature fields. But they are going to have some differences. But the question is really comparing nitrogen rates within these fields. How is the optimal nitrogen rate different between these fields? And in addition to yield, we also measured fruit quality parameters, fruit size, firmness, and then we also measured leaf tissue nitrogen and vegetative growth. And then we're still in the process of developing some of the soil nitrate and ammonium data, the cold hardiness data, and the fruit quality data. But just to go straight into the results. So again, I stress that this is all preliminary, but what we see is that, at least at the outset, is that we do see a strong, significant relationship between, a significant relationship, I should say, between soil organic matter and the amount of nitrogen released in this incubation. But there's a huge amount of variability there. So even though this is a significant relationship, this isn't nearly a tight enough relationship. It's not a strong enough relationship to really be useful. If you can see at this high end, you could, if you say have 40% organic matter, you could have anything across a wide range coming off. So this indicator alone, which is what we were hoping would be kind of, since you already have it in your soil test, a useful indicator for us. I think at least our preliminary conclusion is that this alone isn't accurate enough to predict soil nitrogen release and how you can adjust your fertility guidelines. And so this is from another study that it was done in New Zealand, but just to show that this kind of relationship is not just unique to us. This has also been seen elsewhere in the literature. So this is a study that did a very similar mineralization study, but they specifically only did low organic matter soils because they decided that there was too much variability in the high organic matter soils, that they were too complicated to deal with. And you can see that still they're only explaining, what this means is basically here, we're explaining 31% of the nitrogen release based on soil organic matter. Here, they're explaining 48%. So either way, we want to be able to explain most of that nitrogen release by whatever property we're using to predict it, whether that's soil organic matter or whether that's another property. So there's definitely still a bit more work to do there. From the field experiment, our preliminary results show we didn't see any differences in fruit yield after year 1. So just to orient you here, there's fruit yield in tons per acre on the y-axis, and then we have 4 fields just with their approximate soil organic matter content. Obviously, there's variability within these fields as well, but we really don't see any trends in fruit yield among among nitrogen rates, and no trend for fields that differ in soil organic matter either. And that's really not surprising to us. These are perennial plantings. When we initially just wanted to initiate the study, we figured it would take probably at least 3 years or so to start to see, maybe 2 years, but more likely three plus years, where we might start to see differences in nitrogen management affecting fruit yield. So, and then I'm just gonna talk briefly about fruit quality, because there's really pretty much the same conclusion for a lot of these metrics. So for example, for fruit size, we see there's not really much of a difference yet. And also for fruit firmness, all pretty similar across nitrogen rates. For leaf tissue nitrogen, we also don't see any real differences among treatments, but it is interesting to note that all our leaf tissue nitrogen concentrations were kind of below what the typical guidelines would recommend. I know that in talking to Dr. DeVetter, there has been some questions as to whether we kind of routinely see leaf tissue nutrient contents that are below those guidelines, and whether that might not necessarily be an issue or represent actual deficiency. And for vegetative growth, there's obviously quite a bit of variability, but we don't see any clear differences or trends there, at least in year 1, responding to 1 year of fertilizer. So just to be brief, I only have 10 minutes, but basically just preliminary conclusions. We see that we do have a significant relationship between nitrogen released from soil organic matter and the amount of soil organic matter that's there. But right now it's too weak of a relationship to be useful. And so I think next steps for us are really trying to, one, repeat this result, but also look at what other indicators. So the advantage of soil organic matter is you're already getting it on your soil test, but I think there are other potential indicators. So for example, hot water extractable organic nitrogen, mineralizable carbon. These have been indicators that other studies have found to show better correlation with nitrogen release. And these are things that even if you're not getting it with the soil test you're already doing, you could send out relatively inexpensively to get these tests done separately. So not as good as something you're already getting, but still potentially a useful measure. So we want to explore that relationship. And then for the field experiment, we didn't see any differences in fruit yield or quality among N application rates at any site. But really, as I said before, that really wasn't expected for the first couple years. And so our goal there is to continue that field experiment for at least 3 years to really see if we start to see some differences here and how those differences might vary among sites that vary in organic matter. So with that, I'd really like to thank all our amazing grower collaborators for this project. I'm leaving them anonymous just for the sake of data privacy, but I really appreciate all the help they've given us throughout this experiment and hopefully in future years. I'd like to thank Betsy, our technician, who's been really instrumental in helping with this, Sam, our undergraduate intern, and Shwani, a previous work on the project, the Washington Blueberry Commission for funding this work, and our USDA NEFA project. So with that, I'd be happy to take any questions. I think we don't have the next speaker, so there's a little bit of time.
I don't know. There we go. Hi. I guess this would be more of an observation that a long time ago I was taught that by looking at the color of the leaf and how whether it's yellowing or tree looking, but like my Nuka variety or on my blueberries, if I being up fairly high on them, looking down at them, that I was seeing a reddening, which would tell me that I'm starting to get a little bit of shortage of nitrogen, either whether it's in fruiting time, because already the plant is starting to suffer from it, or the other thing is, like if I use a sawdust mulch, I have to use kind of an extra amount of the nitrogen to help break that down. So when you're speaking of organic, whether it's wood chips you put on or you're in peatland, then it takes a certain amount more to I would really love to have somebody make a book of all the coloring to tell you exactly just by looking at the plant what you're short on.
Mm-hmm. Yeah, that's a great point, and that's something I didn't specify just because we were just for the sake of time. But here we are taking off any mulch layer, so this is just soil organic matter, so we're not including the mulch. But I think we were actually just having a conversation about this at lunch. Kind of mulch and what that's potentially doing to mobilization. And I know Bernadine's done a bit of work on kind of how you adjust nitrogen rates for mulches, but I think there's definitely more to look at there.
In the plant.
Leaf tissue test, yeah, and I believe there's a publication coming out relatively soon that's going to give more guidelines on leaf tissue nutrient contents and kind of help interpret some of those ranges you might see with leaf tissue nutrient testing. Yeah.
Okay. So related to the nitrogen rate you gave that we recommend in our OSU publication, the 165 is for freshly sawdust mulch fields. Otherwise, it's 140. So I just wanted to clarify that. So, and a lot of our fields are weed mats, so they'd be at the 140 at the most for mature based on our recommendations. But the question I had is the graph that you were showing was rate of mineralization, so available nitrate. Do you have any thoughts on how you might extrapolate that to ammonium available nitrogen for blueberries, which don't take up nitrate?
Yeah, so I just showed the nitrate in this. We have more data, but I just kind of basically in this incubation, the ammonium is just incredibly low. So probably we'll lump them together to show, total available nitrogen. But we focus on nitrate for now because that's really where what we saw, what the dominant form was in the incubation.
Yeah, that's always been our thought with high organic matter soils, which we don't have many of in Oregon, is that our soils have a release rate of 70 pounds of nitrogen per acre, even with 3% organic matter. The trouble is that nitrogen is available late in the season when soil temperature is warmer. And so since we know through nitrogen uptake studies in blueberry that they need that nitrogen early in the season, we've always said in our soils that nitrogen isn't available, and that's why we have to fertilize. But with that said, you're right on with our lowest rates that we studied are always similar to higher rates. So they don't need much, but I mean, that's the challenge, and the impact of weed mat on that affects soil temperature and affects what that release curve too. So it'd be interesting to kind of relate this to what is happening in the field. So thank you.
I mean, the temperature sensitivity is a really important part of that. And I think that point about the timing of release is really important. Again, we have other kind of information that I didn't show just for the sake of time, but so we basically did a 6-month incubation and took destructive samples at each month to try and get that time course, because I think that timing of nitrogen release is a really important one. When you are getting high soil temperatures is after peak nitrogen uptake for most of these. So I think looking at kind of what's available during that initial uptake window, and then also what's being released over time, both are important, just so we can kind of get a sense of what's coming off in total, but also to fine tune during that uptake window. So we have looked at that over time, but didn't present it here for time. There you got it. Okay.
I've got one more observation for you.
Yeah.
Quite a while ago, I was kind of curious because they're talking about fertilization leaching. I run a test of from 1 to 3, 3 to 6, and 6 to 9, all straight in the line. Now, mind you, with a perennial variety berries, you're not working the soil much. Anyway, so was never being worked other than just spraying on it or weed killing. It was like morning, noon, and night. All the main part of the fertilizer was in the top 3 inches. And which has kind of surprised me. And then you go to another field that you've been just worked over to put into a crop, it's blended all the way down 12 inches. And so as far as in this soil up here, it doesn't leach down very far at all. Thank you.
Yeah, that's a good point. And I can't really comment on nitrate leaching since we haven't looked at that, but I imagine that's going to depend a lot on nitrogen form, whether it's staying in the ammonium form and you have more of that, or whether it's being converted to nitrate more rapidly. And then also huge interaction with soil type, how sandy or clayey or how much organic matter is in your soils.
Hey, Gabe, you said the nitrogen availability in the leaves and the tissue samples was low. Do you have any idea why that would be?
So I think
below the recommendation.
Yeah, I think 2 things there, and Lisa and I have talked about it a little bit, but one is, we did sample, so, mid-July to kind of early August is the recommended window, and we did sample towards the end of that window. And then the other thing, so there could be, maybe we're on the declining side of that, but I think also a big thing is that we're not unique in seeing this. I think that's been seen by other studies that, routinely fields that seem to be fertilized fine and we're not seeing differences in yields are showing leaf tissue levels that are below kind of the ideal range in those guidelines. So I think there's just somewhat questions about whether those guidelines, maybe don't represent all regions, or maybe there's some more work there to kind of adjust those.
And then the other question would be, as you go forward in this, are you expecting to see any significant change in fruit quality, size, and things like that as you're doing the different variations of nitrogen?
As we go forward in for future years, I really couldn't say. I mean, I think, our expectation is really that, yield in some of the ones with the lower rates, and the lower organic matter could decline over time if we're really under fertilizing them. But in terms of fruit quality, I don't know as much. Yeah.
Then did you see any significant change in between the plants? It's pretty hard this year with just 1 year under your belt, but with lateral growth and things like that in the plant, probably nothing this year.
Yeah, nothing this year. So we ended up focusing on whips rather than laterals, but we didn't see any significant differences this year. Definitely a bit of variability, but yeah, we'll stay tuned for future years if people will continue to work with us. All right, thank you very much.